My guest today is Clemens Vasters. Clemens, how are you, sir?
Very good.
Tell me, what do you do for a living?
I build software.
Software for Microsoft.
At Microsoft.
And you're in charge of what?
I'm the principal technical lead at the Windows Azure Service Bus team.
Okay.
And technical lead means that I'm an architect effectively, but we have a funky title because I'm really on the PM side of the house. We have these three tracks: tests, dev, and PM.
Okay.
And on PM, and typically architects with that title are on the dev side, so I'm a technical lead.
So you're bridging that gap between.
Yeah. So my role is I'm both an ambassador for the product, but I also sit down and write some serious code.
Okay.
So I bridge those two.
That's great. So we've talked a little bit about Azure on this show, but we haven't talked much about the Service Bus. What is the Service Bus?
The Service Bus is a fabric that serves three purposes. One is it provides messaging capabilities, so it gives you queues and topics and pops up functionality for your applications.
Okay.
It bridges the gap between systems that are in the cloud and systems that are on premises with the connectivity functionality. You can go and have a service, a web service that's running somewhere in the data center, and without modifying the data center's firewall rules or having to pull this up into the DMZ, we can act as a DMZ for you, and you can go and take those services and basically project them out into Service Bus.
Okay.
So we're acting effectively as a reverse proxy, if you will. But you can also, if you run an application WCF list service on your notebook, you can, anywhere on a wireless network, you can actually go and expose that out and make that callable from anywhere on a foreign wireless network. And then the third one is something that we're going to go stress more is naming and management. So for you to expose a service like this, to expose a publicly available web service from your notebook on someone's Wi-Fi network in a hotel, you need to have a stable name that you can give to people to hit that. And so we have a naming fabric that gives you effectively a free-form naming tree, and your relays, as we call these relay endpoints, and your queues and your topics and the things that we're going to have in the future, you can go project into that tree, so you get a single surface and a single access control service also for all of your entities.
Okay, that's interesting. So this is a lot of people don't realize, I think, that you don't have to use all pieces of Windows Azure. Part of it can be on premises, part of it can be in the cloud. But the last scenario sounds like none of it's in the cloud. You're just exposing something that's entirely internal.
Yes, so we have
Service Bus.
We actually have several scenarios where customers are using Service Bus with almost no compute or with no compute. So we have scenarios where, for instance, we have one that I keep citing because it's just so exciting, an airline that's actually checking in customers live today. Using, with the help of the Service Bus, where they're using our messaging capabilities, and what their goal is to liberate themselves from the green screen terminals that you have in the terminals, and so they built out of their own data center that they run to run their website with the backend services that already know how to write all the documents that are required. They took the backend services that they have that power their website, where you can go and check in for your flight and do all those things. And they exposed them out on our edge on Service Bus. And they have now, instead of these green screen terminals, they have mobile devices. Those mobile devices talk to our messaging fabric to synchronize amongst themselves the state, and then also talk through Service Bus to their own on-premises service. So they're leveraging the Azure Service Bus as a bus to interconnect all their devices as kind of a communication fabric without even using too much of Windows Azure Compute. Now that they have caught the bug, so to speak, they're going to start moving more things into Windows Azure. But that's a scenario where it's free of Windows Azure. We have other scenarios. I can't talk about the actual scenarios. I'm going to talk about a fictitious scenario, but it's very close to the truth.
Sure.
Imagine you have
a Fabricam company.
Yeah, exactly. So imagine you have, let's say, Litware, and Litware is making software for tax advisors. Okay. So a tax advisor is on the road, and if you have been with a client for a long time, then they have a lengthy history. And of all that data is obviously confidential. So that sits somewhere in a system that you have on site, and you can't easily just move that somewhere in the cloud because it's tax data, and people are sensitive about this.
Sure.
And as good as we can make it in the cloud, people have naturally trust issues with that.
Sure.
Right? Because we're still at the beginning of all these things. So they like to have their server with their hard drives and all that data sitting in the house or in the basement.
They still want to take advantage of other advantages of Windows Azure, like the scalability.
Well, let's say you're a tax advisor,
Right.
and they don't put the data in the cloud. But now that tax advisor is mobile. And so he's walking around, and so he has whatever app. They have a netbook, or they have a tablet, or they have some kind of application. And so they want to have access to the files, but they don't want to load all the files onto their computer because they need to be up to date, and they don't want to carry all that data with them so they can lose it.
Sure, another security risk.
Right. So what we have is customers like this fictitious company, Lidware, which is an ISV, which is providing this software, special software for a tax advisor, which runs effectively a mobile gateway inside of Windows Azure, reaches into the tax advisor's office to their LOB system, and then projects out a set of web services that are then consumed by an application running iOS or Android or in the future Windows 8. And we have production applications that are doing very similar things on iOS today, or ISVs are doing that. But they project exactly those web services that you need for iOS to have a good experience. And then they're communicating from the Windows Azure backplane back into the LOB system. And that link to the LOB system is just done using Service Bus in a combination of the relay capabilities and the messaging capabilities. And so we're creating the bridge for these hybrid systems. And what we call hybrid is you have some parts that are living, for whatever reason, locally on premises, and then you have things that are well hosted because they need to have the scale or the reach that then run in Windows Azure. We're bridging those things.
So that, I think those two examples cover that third scenario, the one where we're reaching into some service or some data in-house. Let's talk about the other two scenarios. You had one with where you've got a sort of hybrid example.
Yeah. So imagine you have an example where so there's purely federated and there's hybrid applications. So let's say. So what we just had is a hybrid application where you effectively just have a proxy, a very smart proxy as a pass-through. Other hybrid solutions are ones where you have significant business functionality in the cloud, and also significant business functionality somewhere on premises. For reasons, let's take reasons that are other than just being worried about data. Sometimes you just have physical devices that you need to go and talk to.
Okay.
So we have a scenario where a good partner of ours, Mr. Bedin was actually with me on stage at the Build conference. He's building a very interesting system for stores, for shops. So the company's called Bedin Shop Systems. And what they're doing is they're building applications for retail stores, and they are feeding pricing information into cash registers. So if you run a retail chain, you want to have your pricing information updated as the market demands and as the market is. So you have a central place where you manage all those things, and you manage that with Bedin Solution, which is backed by Windows Azure. And so all the data lives in Windows Azure. But you also need to flow all the information into the cash register because that's where the action is. You can't run that cash register in the cloud.
You'd lose functionality if you got disconnected.
Exactly.
Right.
So you need to go and update them, and so that's
where Service Bus comes in.
That's what Service Bus comes in. So he uses that application is using Service Bus messaging, our PubSub functionality, to enable them to go and publish the price to one point to the topic, and then every cash register effectively has, or at least every site has a subscription into that topic, and then it gets that data. They're using filtering so that only the sites that are interested in particular updates are actually getting the right data. So that's a hybrid scenario.
So it's a lot like BizTalk message routing.
Yeah, and it's very similar, and it comes from the same stable because the BizTalk team is a partner team or sibling team actually of ours. And the BizTalk team also contributes the integration features for Service Bus. And then the last scenario that I might mention is ticketing. When you think about that, so I have a friend in New Zealand, Chris Alt from Intergen, who's built a very interesting large production ticketing system for a client of theirs. And ticketing is really interesting when you think about it from a federation perspective, because you need to have, if you're selling the largest concerts in the country, And let's say the Rolling Stones come by, or Madonna comes by, like one of the giga, mega.
So demand is going to spike at that time.
Yes. So effectively, you're putting the tickets on the block, and you're going to sell that whole concert out for a week in 5 minutes. So you need to have that capacity. Now, there's a ton of other events which have tickets left as when the day comes.
Right.
So now you have tickets to sell. So now you have 400 people lined up in front of the box office, and it's 20 minutes before the concert starts, and now your internet connection snaps. What are you going to do? So that's not tolerable. So what you need is you need to have a local system that is fully functional and works. As long as you have power, you can sell tickets. And dealing with power is easy. You can put a generator in the back office.
Right.
But internet is harder. And then you have a fully functional and super scalable system that scales up to the demand that you would have the spike at 5 minutes with selling hundreds of thousands of tickets in the cloud. And those is effectively the same system, but it runs in different places, and they need to go in synchronized state between each other.
Okay.
And that's what I call a federated system, and that federation is also facilitated by Service Bus.
So what are these endpoints on the service bus? You've got one pointing to maybe an premises and one to something on the cloud. Are these WCF endpoints? Are they queues or what?
So we have two fundamental capabilities. One is messaging. And messaging, we have our own model that is currently based on a proprietary set of protocols. As an interim solution, we've been engaging with the AMQP community, AMQP Advanced Message Queuing Protocol, since 2008, and we've tried to help them and succeeded in establishing the AMQP 1.0 protocol. And so that's a protocol we're going to snap to in one of the next releases. But until then, we have our own custom proprietary protocol built on WCF. That is a messaging protocol and has a different kind of message from what you know as the WCF message. So it's effectively, think of it as the HTTP frame with the key value pairs and then the body inside of it, and that's what we flow over the wire. And then we're going to have the same thing on AMQP. So think of that as a low-level messaging capability. And we have a queue, and we have a topic. Topic is like a queue, but it has multiple outs, and it can have filters on those outs. And then we have a WCF adapter on this, a binding, the net messaging binding, where you can go and use the WCF programming model on top of this. So you can either go and use our messaging API, grand and powerful, or you can make it a little easier and use the net messaging binding. For the relay, we have a WCF API, and right now only a WCF API. So we're looking to also base that on an open standard. AMQP is specifically for asynchronous messaging, so we're looking into several alternatives, open alternatives for the synchronous messaging path as well.
Okay, so the queues you're talking about here, are these the same queues that we'd use in Azure Storage?
It's a different queuing system.
Okay.
So we have, effectively, our queues are specializations of the PubSub infrastructure that we built. Okay. So if you want to look at it like this, we have a topic with a single subscription, and the subscription has a rule that says pass all messages. Right. And we have taken that path and basically optimized it. So it's effectively, the queue is just a natural part of any PubSub system, so that's why we have it.
Okay. I heard a story that you were one time used the service bus to get German soccer games available in another country. Is that true?
Yeah, yes. So I'm still running that kind of setup. I'm going on the service bus, off the service bus, on the service bus, off the service bus, because I'm experimenting with things. So right now I'm actually running some experimental protocol kind of directly, because I'm trying things out to see how far we can push things. Okay. And so I'm using myself as a lab rat. But so I'm for some time I've been running it through the service bus, and the piece I'm still running through service bus is I have a bridgehead machine basically in Germany at my parents' house. Okay. And so has a service bus listener that's on all the time, and that particular service bus listener is bridging to an HTTP proxy server. So it basically takes the socket of the HTTP proxy server and pulls that over into my house. So the dial code from the US to Germany is 1149. So It's 1149 is the port that it looks out in my house. And so we point Firefox to it. So whenever we need to browse from Germany,
Okay.
we'll just open Firefox, and that goes through service bus into the house in Germany, pops out in the house in Germany, goes to the proxy server, and then we're...
And you're pulling streaming video.
Yeah,
across
so
the
you can
servers.
actually, yeah,
That's
it's
a lot
good.
of data.
Yeah, it's good enough to pull streaming videos. I can get about 1.2 megabits. So if you think about how TCP works with the throttling imposed by latency,
Okay.
for the route between Mönchengladbach, city in Germany where that machine sits, and here, it's about 200 milliseconds latency. So when you think about how TCP works, it's about 1.5 to 2 megabits at most that you can get out of that link. And I can get, even though I'm going all that complicated route, I can get about 1 to 1.2 megabits. So I'm getting as much as I could over a regular TCP link.
Not bad. You get to follow your favorite soccer team, Bayern München.
No, it's Borussia Mönchengladbach. Well, that's very important. Bayern
we
Munich
have
is
my favorite teams here.
Bayern Munich are the bad enemies. Yeah, I'm following U.S. sports too, but after I caught the baseball bug, 2 years later, I unfortunately found out that Mariners are not very good.
That's part of the fun.
Yes.
Anything else?
Yes, Service Bus is still free
Okay.
to use. So
What is? I didn't know that.
yes, so we are.
So those scenarios that don't have a compute aspect to it, they're 100% free.
So right now, we still are in a promotional period. The promotional period, I think, officially ends at the end of this month, March.
Okay.
Tomorrow's
March, actually. It's leap year.
Yeah, I thought you would publish it tomorrow.
Good point.
And so the promotional period ends at the end of the month. However, it looks very much like it that it's going to be extended for a little bit, a month or two.
Okay.
We're going to announce that ahead of time so nobody gets caught by surprise. But you can use those features now, and then once we start charging, it's on the messaging features, it's per 10,000 messages, 1 cent. 10,000 payload messages. So if you come up and do long polling, whatever we do in Keep Alive, you don't pay for that. But 10,000 payload messages, 1 cent. And then if you use relay for 100 relay hours, so 100 hours that you have a single endpoint sitting there that you have at least one listener hooked up to, you pay 10 cents for 100 relay hours. So it's not really expensive. It's actually quite cheap for a messaging infrastructure.
Okay. And you're writing a lot about the service bus.
Whenever there's need to write, I do write. I used to be a more prolific blogger than I am now, but you can follow me
today.
Yeah, so you can follow me. I think the most output I'm putting in Twitter, so you can follow me on Twitter at Clemens V, CLEMENSV, and I'm also at vasters.com/ClemensV. That's my blog. I have also a Clemens V MSDN blog, so I'm synchronizing the content across those. So you can find it everywhere.
All right. Well, thank you very much.
You're welcome.
Very educational.
So when I'm watching my soccer games at 6:30 in the morning U.S. time when the games are on, I'm often chatting also with my friends on Twitter about technology.